In this video, we're going to talk about domain. Now, unless otherwise stated, assume that the domain of any function defined by a formula or an equation is the largest set of real numbers, or inputs, that each produce a real number as output. Okay, let's do some examples. Each of the given equations defines y as a function of x. So x is the input and y is the output. Find the domain of each function. Now in part A, the question is, what numbers can you plug in for x that will give you a real number as an output? Well, you can put in any number that you want. So what we would say is that the domain is all real numbers. Okay, now in interval notation, we could say it's really the interval from minus infinity to positive infinity. So maybe that would be the way to write the answer. Okay, in the second part B, what numbers can we plug in for x that would give us an output for y? Well, we can plug in any number we want for x except 5. If we plug in 5, 5 minus 5 is 0, and 1 over 0 is not defined. So this would be all real numbers, okay, except 5. Now, the way to write that is it's the interval from minus infinity to 5, okay, open interval, or 5 to infinity. Okay, these would be all of the numbers that are less than 5. This is all of the numbers that are greater than 5. But that does not include 5 itself. Okay, so all real numbers except 5. Okay, now part C, we can plug in any numbers we want, again, for x, except the one thing we have to be careful of is that the square root, we cannot take the square root of a negative number. So in other words, we want x minus 7 to be greater than or equal to 0. Okay, if you take the square root of a negative number, you'd end up with an imaginary number, but we want y to be a real number. Okay, adding 7 to both sides, what we see is that x is greater than or equal to 7. Okay, so that's our domain, all values of x that are greater than or equal to 7. Now, we could write this in interval notation as it's the interval from 7 to infinity. Now, I put a closed bracket at 7 because it does include 7 itself. Okay, now here we want 3 minus x to be greater than or equal to 0. We can't take the square root of a negative number again. Now, if I add x to both sides, what we see is that 3 is greater than or equal to x. Okay, now another way of writing 3 is greater than or equal to x is less than or equal to 3. Okay, so we're looking at the interval from minus infinity all the way up to 3. That would be the domain. Now, in the last case, we have to be careful of two things. We don't want to take the square root of a negative number, so we want x to be greater than or equal to 0, but also we don't want to be dividing by 0. Now, we can rewrite this by factoring the denominator as x minus 4, x minus 1. Okay, now notice I do not want x to be 4. Otherwise, this factor would be 0, and when you multiply 0 by whatever this is, I guess it would be 3, right? The whole thing would be 0. So you cannot divide by 0, so x cannot be 4, and x cannot be 1. Okay, so what are we looking at? Well, we're looking at all of the numbers that are between 0 and 1, okay, or that are between 1 and 4, or that are between 4 and infinity. Okay, now 0 itself is okay. It's okay to plug in 0. You can take the square root of 0. That makes sense. But you cannot plug in 1 or 4. So another way of saying that we're just looking at the positive numbers other than 1 or 4 is this.